Yo, Mrs. Luke, let's kick it. Now listen up. We're learning about equilibrium, reviewing old concepts, yet we're killing them. Constants, yeah, we're talking KC. If you sure to listen well, you'll get higher than a B. Looking at the numbers, concentrations, filling in the table with our mind racing. Once you fill it out, it's easy from there. Just plug and chug along and get the answer, I swear. Math, it's what we're doing right now. You use your calculator, sure somehow have the quadratic formula or you're done. That's the only way you'll get some answers, hon. It's products over reactants every time, even when putting it in this rhyme. That's of course how you get the KC. After all, this is really pretty easy. Ice, ice, table. Ice, ice, table. Ice, ice, table. Ice, ice, table. Initial change in equilibrium, that's what it is now, don't be dumb. Homogeneous and heterogeneous too, both equilibriums, but there's more too. We can talk about acids and bases as well, but you better get it in before the bell. Same concepts apply to these, you see. I'm teaching it to you without a fee. Now moving on, there's more to discuss. Settle yourself, I don't want any fuss. Look at the principle of the Chatelier, it's easy, doesn't need much care. It says add to one side, subtract from the other. That's some simple common sense there, brother. Glad you could join us for this fun, for this rap that was hotter than the sun. We out here, AP Chem hits 2K16.
Yeah, Mrs. Luke, AP Chem, AP Chem, Vesper, them boys trying to model. They just spent like 2 whole periods learning about electrons. Count your total number of electron pairs. Arrange them around each atom like a Lewis structure. Now use the theory to predict the shape. Find how many total pairs, uno a seis. Lone and bonding pairs set the final shape. From linear to square, planar we set it up. Vesper, they still trying to model. We ain't finished with this yet. Dipole moment is our next big topic. Demonstrates electric charge and polarity, plus and minus charge on these bonds. Dipole, we still got those vectors. Dipole, magnitude and direction. Dipole, Gilbert Lewis just said watch me. Lewis. He just had a thought of a good connection. Use his formula to pick acids and bases. Acid, Lewis acids take them. They the ones that want to take electrons in. Have their charge decrease when they bring them in. Base. They the opposite of what we just said. Bases are the ones that give the pairs. Electron pair donor is what they choose to be. It's just much better than Arrhenius. Requires using all the things that you have learned. AP Chem Tracks, 2K16.
Dang, back at it again with the equilibrium. Acids and bases both in our faces, filling the spaces with concentrations. Don't use Kc, instead use Kb, also Ka. If you wanna stay in AP Chem, then you will spend multiple hours learning what powers equilibrium. It isn't dumb, this is good fun, but we're not done. How do we show what we now know? Many ways to, here are a few. pH and more, that is in store. Polyprotic acids for those chem classes. Finding Ka. Finding Kb. On in heads, hope that you read 15 and 16, you'll be supreme. H3O plus, that is a must when using acids. Wear safety glasses, then onto bases with ionizations. Their constants to listen for rules. Rules are the same in this fun game. Products over reactants, then you must practice moving on to buffers and stocking stuffers. Use indicators showing the haters this ain't so bad. Why are you mad? You've heard it already, just get it Freddy. pH and more has been restored. We're done this many times before. Anderson and Hasselbach, Anderson and Hasselbach. On in heads, hope that you read, hope that you read, hope that you read.
Oh my gosh, Mrs. Luke, look at that molecule. It is so soluble. It looks like one of those that makes strong electrolytes, but you know, who understands solubility? We only learn it because you make us, right? I mean, solubility, it's just so confusing. I can't believe it can be so simple. It's like, not hard. I mean, wow. Look, it's just so interesting. I like solubility and I cannot lie. You other chemists can't deny that when a problem comes up with a complex molecule and ask for a KSP, you get solving. When I figure it out, because you know how if you don't pound, start with table 4.1 and find if it's soluble. No chem. This is the prep, so please don't take a side step. My classmates tried to warn me, but that solubility makes me so nerdy. Oh, chem baby, you say you want to solve for KSP? Well, don't forget me, says poor old chapter 12. I've seen its contents. It really ain't nonsense. It's good, right? So don't put up a fight. It talks about Henry and his law of solubility for relating pressure of a gas in a wet. Make sure you calculate net. So chemists, have you started to understand? So use it. Flaunt those new chem skills. Solubility. Solubility. I like this next part, so please take it straight to heart. You got some limits, don't act like an animal. Your answers will be a scandal. I want to get in the lab, and 1, 2. There are exceptions that may cause some tensions. Temperature and pressure. High temp bumps it up. It makes the solubility greater, and the same vice versa haters. So pressure changes demonstrated when the shot of the air concentrated to create a good principle that isn't at all mythical. Now on to 17, it's now your time. Show us what you got. We know for KSP we take concentrations of the slightly soluble reactants and multiply them all together to give us our final value that we can check on page 703, table 17.1. Has them there for me. So chemists, do you finally understand? Then apron up, goggle up, and get out and use those skills. Solubility. Solubility. Solubility.